The principle of zero products states that if A times B, if a product is equal to 0, if the answer to a multiplication problem is equal to 0, then one of the things at least that you're multiplying by has to be 0. If we've got a problem like 3 times 7 times negative 12.4 times 75 fourths times 2.661 times 0 equals what? You don't need a calculator because one of the things you're multiplying by is 0, so the answer is 0. So if we can take a problem and rewrite it so that it is a product, then we have the ability to find out what will make any of the factors equal to 0, and that's also going to be an answer. Suppose we had something like 6x squared minus 6x plus 8 is equal to 0. Now there's all kinds of combinations of things that will add together that equal 0, and when you break them up into 3 things, then you've got a mess on your hands. But if we can rewrite this as a multiplication problem, which is exactly what factoring means, then anything that would make either factor equal to 0 will make the whole thing equal to 0. So when we're factoring this, since this is just a plain x squared, the only way to get x squared is going to be x times x. Here we have 8. Let's look at the possible factors of 8. 1 times 8 or 2 times 4. We want factors of 8 that add up to 6. Start at the end of the problem and work your way to the left. So we want factors of this that do this to give us this. And I'm not even worried about the negative in front of the 6 yet. This adds up to 9. This adds up to 6. Bingo. So this is going to be a 2 and a 4. Factors of 8 that add up to 6. Now, to get this to actually work out so that when we multiply it out, we'll get a negative 6. To add these two numbers so that they come up with a negative 6, they're both going to have to be negative. And if you multiply this out, you'll see that you get this. So if I can find something that'll make x minus 2 equal to 0, then it wouldn't matter what x minus 4 was, the answer would be 0. Likewise, anything that'll make x minus 4 equal to 0 will make the whole thing 0. This, if I add 2 to both sides, gives me 2. This, if I add 4 to both sides, gives me 4. Now we can check this. If I put a 2 in place of the x, then I've got 2 squared minus 6 times 2 plus 8 should equal 0. This is 4 minus 12 plus 8. 4 and 8 is 12. 12 minus 12 is 0. So this is 0 equals 0. This is kind of a question mark here, but at this point it's absolutely certain that the solutions are indeed 2 and 4. Let's try another one. What if we had x squared minus 2x, minus 3 equals 0. Now, rule number 1 is that you have to have a 0. This must be 0. If this is not already 0, then subtract everything off of one side so that you have nothing left on one side. Because 0 is the only solution over here where knowing one of the answers to the factor will give you the answer to the whole problem. 0 is kind of the Superman of numbers. It's a kind of meek and mild Clark Kent when you're adding, because when you're adding 0, it does absolutely nothing. But when you multiply by 0, all of a sudden, this is the only problem in the world where you only have to know one of the numbers in order to know the answer to the whole thing. If it's a multiplication problem and you're multiplying by 0, it doesn't matter if you have 500 other numbers, none of them count. So 0 is the Superman of multiplication. Now, if I look at this, again, this is just a plain x squared here. So I want factors of 3. Well, I've got 1 and 3 to choose from. I want factors of 3 that when I subtract will give me 2. Fortunately, the difference of these is 2. So it's going to be an x and an x. It'll have to be the 1 and the 3. Doesn't matter the order. And now to get these two to add up to -2, it would have to be a -3 and a +1. And I suggest you, if you're not real practiced up at factoring, go ahead and stop this, multiply it back out, and confirm to yourself that this is right. So if I can find something that'll make either factor equal to 0, it'll work. In this case, x would be -1. In this case, x would be +3. Here's your answers. Now let's look at one other example. What if we had, say, x squared minus 4 equals 0? These are this is a difference of squares. This is your best friend when it comes to factoring. If you have a square, and x squared is obviously something squared, minus, hence it's called a difference, another square, and 4 we know is 2 squared. A difference of squares, a squared minus b squared, will always factor into what we call conjugates. The square root of the first one, a plus and a minus, and the square root of the second one. Conjugates are super, super important in math. This is the only combination where you can FOIL 2 binomials and only get 2 terms in your answer. So this will factor into x and x, the square root of the first one, a plus and a minus, and then the square root of 4 is 2 and 2. If you multiply this out, you'll see that the middle terms cancel. So the answer to this one is -2, and the answer to this one is +2. Now, you probably had a feeling it was going to have something to do with 2 when you saw that it's something squared, -4 is 0. So you were thinking in terms of this. That actually will take us to another rule called the principle of square roots. The principle of square roots says that if you have something squared equal to a number, then the solution, or solutions, should I say, will be the positive and negative square root of that number. So I could have said, if x squared is equal to 4, then x is going to equal plus and minus the square root of 4, or x is going to equal plus or minus square root of 4 is 2. And this is an abbreviation for writing 2 and -2, so that we don't work the problem out twice to get the positive square root and the negative square root. This will work for things that won't even factor, provided you do not have a middle term. If I had x squared equals 5, then I could say, well, x is going to equal plus or minus the square root of 5, and that one won't even reduce, so that's done. What about x squared equals 12? Well, then x equals plus or minus the square root of 12, which would be plus or minus the square root of 4 times 3, plus or minus the square root of 4 times the square root of 3 would be plus or minus 2 times the square root of 3. And this would not have factored. This, if we're not restricted to real numbers, would even let us take something like x squared plus 9 equals 0, which will not factor. You can only factor a difference of squares. You cannot factor a sum of squares, because if we subtract 9 from both sides, I'm going to get x squared equals -9. So x is equal to plus or minus the square root of -9, which is going to be plus or minus, the negative means we're going to have an I, the square root of 9 is 3, so it's plus or minus 3i. This you want to use only if there is no middle term. Now, there is another type of another method for solving called a completing the square. I am not going to go through completing the square, because if you take your most general possible conceivable quadratic equation, ax squared plus bx plus c equals 0, and you follow through the process of solving for this using the method of completing the square, you will discover that x will always equal the opposite of b plus or minus the square root of b squared minus 4 times a times c, with the whole entire thing divided by 2a. This is called the quadratic formula. And it is the end result of completing the square. And generally, it's easier to just go ahead and take the end result. The a, b, and c in the formula here come from the numbers here. You just plug them in and just simplify. So let's look back at, what was it, x squared minus 6x plus 8 equals 0. Now, first of all, you have to have this condition met. You still have to have a 0 over here. In this case, a will equal 1, because this is a 1x squared. A, b, and c are never going to be the x itself. b is -6. C is 8. So if I plug these into the formula, I'm going to get negative b, so minus -6, plus or minus the square root of b squared minus 4 times a times c, and the whole entire thing, make sure you draw the whole line here, over 2a. So the first time through, there's 3 things you want to look at. You want to look at this, 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 and this, always. So if you have minus a negative here, that's going to change the sign. Plus or minus the square root of -6 squared. This is the entire b, whatever it is, squared. So this will always be positive. This product could be positive or negative depending on whether or not the a and the c are negative. If one of these is negative and then you got this negative, it'll turn back to a positive. If they were both negative, so there are 3 negatives, it'll stay negative. Or of course, if these are both positive, it stays negative. So this is going to be minus 4 times 1 is 4 times 8 is 32. All over 2. Now the next time through, you can only do one thing. Combine these two. So in the next step, it's going to be 6 plus or minus the square root of 36 minus 32 is 4 over 2. Square root of 4 is 2, so this is 6 plus or minus 2 over 2. Now at this point, if you cannot reduce this radical, you're done. You don't really need to do anything else. This radical reduces down to an integer, which means that these are like terms and we can actually combine these. So keeping in mind that the plus is one problem and the minus is another, we've got 6 plus 2 over 2, and then we've got 6 minus 2 over 2 to take care of. So this is 8 over 2 is 4, and this is 4 over 4. Wait a minute, sorry, this is, oh, I know what's wrong. Sorry, I was thinking too far ahead. Why didn't you tell me? That's a 2. See, even teachers do that sometimes. So that's a 2, and 4 over 2 is 2. That's bad when you know what the answer to the problem is and then it's not coming out. So we know the answers here are 4 and 2 because we saw that we got the same thing back here. The method that you use to solve the problem is irrelevant. The answers are the answers and they do not change. It's like if you're going home, you might choose to go one route or you might choose to go another route, but you're still going to end up at home, right? So let me put the quadratic formula up here again. Negative b, or the opposite of b, plus or minus the square root of b squared, minus 4ac, all 3 numbers get in the radical, over 2 times a. What if we looked at a problem like, let me find a good example. How about 2x squared minus 1 equals 3x. Okay, rule number 1. This only applies if ax squared plus bx plus c is equal to 0. So this is a problem. All I have to do to get a 0 over here is subtract 3x from both sides. However, I want to make sure that I'm going to put the 3x in the middle. If you have any like terms when you do that, you need to combine those so that it's in this format with your x squared term, and then your x, and then your constant. So now I've got a is 2, b is -3, c is -1. So x is going to equal the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so remember, first time through. 1, 2, 3, 4 spots to worry about. The first step is the only time that you can do more than one thing. So minus a -3 is +3, plus or minus the square root of 9. Because there's 2 negatives, this is going to be plus. 4 times 2 is 8, times 1 is still 8. Over 2 times 2 is 4. So we've got 3 plus or minus the square root of 17 over 4. There's nothing we can do with this. We could write it, if we wished, as 3/4 plus or minus the square root of 17/4. But I don't see that that's really going to get us anywhere. So you need to make sure you practice the quadratic formula. Now, what if we had a problem that came out to something like 5x squared plus 10 equals 0. Now we actually could, because there's no middle term, use the product of square roots. In other words, solve this for x squared by subtracting the 10 and dividing by 5. But I want to go ahead and practice using the quadratic formula. Factoring only works on a very small number of problems, but if it'll factor easily, that's usually the quickest thing to do. Using the square root only works well if there's no middle term. If there's a middle term, then you have to go to the completing the square method, in which case you might as well use the quadratic formula. So I'm going to go ahead and use the quadratic formula, which will work on any problem, whether another method would work or not. So a is 5, b is 0 because it's the x term that's missing. The 10 is our c. So we've got x equals the negative of b is 0 plus or minus the square root of 0 squared minus 4 times 5 times 10, 4 times a times c over 2 times a. B can be 0 and or c can be 0. A can't be 0 because if it is, you don't have an x squared, and so it wouldn't qualify as a quadratic at all. -0 is nothing. Don't need it, so that's plus or minus the square root of. That's a 0 minus 4 times 5 is 20 times 10. 20 times 10 is 200. Divided by 10. Now, notice we've got a negative number in the radical. The quadratic formula doesn't care. The quadratic formula is the, well, on the square roots, you could have a negative under your radical. The negative in the radical, as long as it's nothing we have to graph, in which case we just say, well, that's not something we can graph. This negative will come out as an I. And I just have to worry about how to reduce the square root of 200. Well, actually, I can write 200 as 100 times 2. That would be the best thing. So I've got plus or minus I. The square root of 100 is going to be 10. The square root of 2 is hopeless. Divided by 10. Now, normally I would move the 10 to the front of the I, but these just cancel. So my two solutions are going to be plus or minus the square root of 2, I. Now, sometimes you'll run into what they call quadratic form. Quadratic form problems have something squared, and then in your middle term, you're going to have that not squared. For instance, what if this had been an x squared? And this would be an x squared. So suppose we had an x to the 4th and an x squared. Or we could have an x to the 6th and an x cubed. Or x to the 8th and x to the 4th. Anytime this exponent is double this exponent, it's a quadratic form. So if we had, say, x to the 4th minus 5x squared plus 6 equals 0. This would have factored. We can factor this also, but instead of an x and an x, we're going to put whatever we've got in the middle here. So it's going to be x squared and x squared. That takes care of the variables. That part's done. We want factors of 6 that add up to 5. That's 2 and 3. To get a negative 5, it's got to be a negative 2 and a negative 3. Set my factors equal to 0. So I get x squared is 2, x squared is 3. This is going to be x equals plus or minus the square root of 3. X equals plus or minus the square root of 2. So for an x to the 4th, I get 4 answers. 2, square root of 2, negative square root of 2, square root of 3, and the negative square root of 3. So that's a quadratic form type problem. So those are trickier. It is possible to have something where you have to use the quadratic formula on those. If you do, the quadratic formula is giving you x squared equals negative b plus or minus, et cetera, et cetera. And when you get to the end, you still have to take plus or minus the square root. That's everything there is to know about solving a quadratic formula, or even a almost quadratic formula. Let me know if you have any questions, and I will talk to you later.